Okay, sorry you guys, it's going to be periodic table part 2 because now we have to go over the properties. There are some properties of the elements that you need to know. Okay, the first thing you're going to need to know is, let's do atomic radius. Then let's do ionic radius. Then let's do ionization energy. And 4 would be electronegativity. Okay, let's get some definitions. Atomic radius is half the distance between two nuclei in the solid phase. Okay, and there actually is a table that you have in your reference tables from me that gives you the atomic radius in picometers. Okay, so if I look at, let's take helium, and you have a helium atom and another helium atom. Okay, and if I look that up on table S, it says it's 50 picometers. That means half the distance is equal to 50 picometers. That means the total distance would be 100. Okay? So that's the definition. But what's the trend? Now, of course, you could look them all up and then plot a graph like I made you do during our study on the periodic table, or you can memorize the trend. Here's the trend. Remember? When you go down a family, atomic radius increases. When you go down a family, atomic radius gets bigger. Why? Because you're going into higher energy levels. Remember, energy level has to do with distance from the nucleus. So of course an atom, n equals 2, is going to be smaller than an atom that has electrons in n equals 7. When you go down a family, atomic radius increases. Now what happens when you go across a period? When you go across a period, atomic radius decreases. Atoms get smaller when you go across a period. That's because you're adding protons into the nucleus, and the electrons that are going into the same energy level, they're being pulled in more tightly. Okay? So, where would your largest atoms be? Right here. The largest. Where would the smallest be? Up here. Okay? So who's generally bigger? A metal or a nonmetal? A metal is bigger. Nonmetals are smaller. Now ionic radius has to do with the following. What's the difference between a magnesium atom and a magnesium ion? The ion is smaller. Positive ions are smaller than their atoms. But what about oxygen versus the oxide ion? The oxide ion is bigger because when something gains electrons, it's going to get bigger. Okay? So positive ions are smaller, negative ions are bigger. Now let's do ionization energy. Ionization energy is the amount of energy needed to steal someone's electron. Now, listen to this because this is important. The lower the ionization energy, the easier it is to steal an electron. The lower the ionization energy, the easier it is to steal its electron. Who would be the one who would be the easiest to steal its electron? Well, it's going to be a metal. You know that because metals want to lose electrons. But it's also going to be the biggest element because that outermost electron is further away, so it's going to be easier to steal that electron. Ready? So here is the trend. When you go down a family, ionization energy decreases. The bigger the atom, the lower the ionization energy. The bigger the atom, the lower the ionization energy. So that should give you a prediction right here. What's going to happen to ionization energy when you go across a period? Ionization energy is going to increase because these are your smallest atoms anyway. Plus, they don't want to lose electrons. These are your nonmetals. They want to gain electrons. Ready? Noble gases have the highest ionization energy. Alkali metals have the lowest ionization energy. Okay? Now let's do the last one, electronegativity. This is a measure of how much an atom wants to gain an electron or pull the electron closer to itself in a chemical bond. Okay? So here's the trend. The trend is this. Metals don't want to gain electrons, they want to lose them. Metals have low electronegativities. When you go down a family, electronegativity decreases. Now, who wants to gain electrons more than any other element on the periodic table? We know that it's going to be fluorine. Fluorine has the highest electronegativity. Fluorine has an electronegativity of 4.0. It's the man. If there's ever a contest between fluorine and another atom for an electron, fluorine's going to win. When you go across a period, electronegativity tends to increase. However, why don't noble gases have an electronegativity? Noble gases don't want to gain electrons. They're not going to form chemical bonds, so they don't even have an electronegativity. Okay? Because they already have their 8 valence electrons. They're stable. Leave me alone. I don't want to gain any. Okay? So fluorine, your halogens, have your highest electronegativities. So let's do a review. Ready? When you go down a family, atomic radius increases. When you go across a period, atomic radius decreases. When you go down a family, ionization energy and electronegativity both decrease. When you go across a period, ionization energy and electronegativity both increase.